In this video, I want to start talking a little bit about logic and what that means. Also, you've noticed, at least for the next couple of videos, I'm going to try writing on a printed version and see if that helps. It just saves time for me making the video, and it might be a little clearer for you guys to read. So what we're talking about here is kind of an introduction to logic, and logic is a way of determining and dealing with the truth of various statements and how truth of various statements can play together. This is going to be an important concept for us mathematically, as when we want to prove statements, which will come very quickly, we want to determine the truth values. We have to figure out what that means. So first of all, we need to determine the truth value of various statements. So let me tell you what they are. So we're going to talk about statements and open sentences here. So obviously there are various types of sentences in the English language, and not all of them are statements. Statements are sentences that are definitively either true or false. So you can characterize a statement as either being true or being false. There's some other types of statements out there. They have different names like declarative and imperative and questions, things like that. But the whole point is, if you can't definitively say if it's true or false, it's not a statement. Now, there are types of sentences called open sentences, and open sentences turn into a statement if you fill in an appropriate value in a variable. And we'll show a couple of examples about this in a second. And of course, when we have variables, we need to talk about what you're allowed to put into these variables, and that's called the domain. What we're allowed to input is called the domain. So let's do a little example here. This is just example 2.1. We want to determine if these are either statements or open sentences or neither. If they're statements, let's say if they're true or false. If they're open sentences, let's determine when they're true and when they're false. And if they're neither, we'll just say they're neither. Okay, let's go. So the first one, pi is equal to 3.14. Well, this is not true because pi is an irrational number. It is a number whose decimal expansion goes off infinitely far to the right. So 3.14, it's an approximation of pi, but it doesn't equal pi. Even if it's close, if it's not exact, it doesn't equal. So this here is a false statement. If we look at this one, x squared equals 1, and we're saying here x is a variable, and x is some integer. So this is telling us what our domain is. Our domain is the integers. We're allowed to put in integers here. So for the second one, this is an open sentence, and it's going to be true for the integers, of course. Well, what integers, when you square them, you get 1. It's 1 and negative 1. So it's true when x is either plus or minus 1, and it's false for any other value. So false otherwise. So the second one is an open sentence, which is true for x equals 1 and x equals negative 1, and false otherwise. The third one, how old is Queen Elizabeth? Well, that's neither true or false. It's a question. There's no variable in it, anything like that. This indeed is neither. So I'll just write neither. Okay. Let's look at the next one. Add 3 and 5. Well, that's telling us to do something. It's not something we can say is definitively true or false. It's not an open sentence. There's no variable that when you fill it in, it becomes a true or false statement. This is, again, neither. Okay. Let's look at this sentence. So this is the capital of province P is Halifax. So it tells us our domain here. Our domain is Canadian provinces, and our variable is P. So it's looking like this is going to be an open sentence. And when is this true? For what province P is the capital Halifax? And of course, that is Nova Scotia. So it's true when P is Nova Scotia, and false for any other value. False otherwise. All right. Let's look at the next two almost together. You can see that the statements, or I should say the sentences, are the same. They're both open sentences with a variable, but the domain is different. So for the first one, A is an integer. For the second one, A is a rational number. So let's think about this. If we had this equation, 3a plus 1 equals 6, let's try and solve that. We know how to solve equations. 3a plus 1 equals 6. Let's subtract 1 from both sides. 3a equals 5. Divide both sides by 3. We get a is 5/3. So it looks like this equation has a solution when a equals 5/3. But for this open sentence, 5/3 isn't part of our domain. Our domain is integers. Remember, integers are positive and negative counting numbers along with 0. So 5/3 isn't part of our domain. So this equation here is always false. So it's false for all integers, even though there's a variable in it. You can think of it as an open sentence that's always false. The second one, well, now we're allowed to have rational numbers. We're allowed to have fractions. So this number 5/3, we're allowed to put that in our equation here. So it does make the equation true. So it's true when when a is 5/3, and that's the only solution to this equation, so it's false otherwise. Okay, the next two, I'm just going to introduce these a little bit. I want to point out a couple of things about them. First of all, we do have a variable involved, and there is kind of a domain. You can see that here. But also, there are these words here, there is and for all. And you could look at this, and you could think, all right, there's a variable with a domain, so maybe this is an open sentence. But let's think about this intuitively. Remember, statements are definitively true or false. So if somebody just said, there's a real number, x, such that x squared equals 2, you'd say, yeah, that's true. Square root 2 squared is 2. That's a definition of square root 2. So this is true. This is a true statement. And in fact, these terms, there is and for all, they're called quantifiers. They give some indication about how many objects in a domain you want to talk about. So here it says there is a value, which means we're just looking for one. So there is a value, a real number, x, such that x squared equals 2. That's true. In fact, there's two of them, plus square root 2 and minus square root 2. So this is true. And it's just true. It's not an open sentence. It's just a true statement, because we know all it's asking is there a real number so that x squared equals 2? There is. So it's telling the truth. For the next one, for all real numbers s squared doesn't equal 0. Is that true? Well, you'd say, no, that's not true. 0 squared is 0. 0 is a real number. So it looks like this is false. It's not true that all numbers, when you square them, you don't get 0. 0 squared is 0. So even though there's a bit of an open sentence part, when you get this kind of quantification going on, which we're going to talk about in more detail in the future, it turns it into a statement. So this is a false statement. So this idea of statements determining when they're true or false in open sentences will come up throughout the course. This is something we'll use over and over again.